Welcome to Operations Management. This is the third part of the lecture, and here in this lecture we will think about exponential smoothing method. Third method is exponential smoothing method. Exponential smoothing method is a form of weighted moving average, meaning that weights can decline exponentially, and most recent data weighted the most. And the second thing about exponential smoothing method is that it requires smoothing constant alpha. And alpha ranges from 0 to 1, and it is subjectively chosen by the forecaster. It also involves little record keeping of past data, which is an advantage over moving average method. Here's the formula for exponential smoothing method. A new forecast equals last period's forecast plus alpha times last period's actual demand minus last period's forecast. And in a mathematical format, it's Ft equals Ft minus 1 plus alpha times At minus 1 minus Ft minus 1. Here, Ft stands for new forecast, Ft minus 1 is previous forecast, and alpha is smoothing constant, and At minus 1 is actual sales in the previous period. So that's what it means. And here I don't want you to be scared by Ft and Ft minus 1 and At minus 1. It's simply a time series, meaning that if Ft, T stands for, say, today, then T minus 1 will be yesterday. Say T is this month, then Ft minus 1 means the forecast at last month. At minus 1 will be the actual data last month. So don't be scared by or surprised by this time series term. Here, let's take an example of exponential smoothing method. Say we have predicted demand is 142 Ford Mustangs, and actual demand is 153, and smoothing constant equals 0.2. So it's already given, and we want to calculate exponential smoothing method. So we know that the formula is given like this, and our job is just to plug in every number. And predicted demand is 142, right? And the smoothing constant is 0.2, and 153 is actual demand. So we just plug those numbers in the formula, and you find that it's 144 cars. Exponential smoothing method is fairly straightforward. What is important is to choose the right constant alpha. When do you choose high values of alpha and when not? It all depends on sensitivity. If you, as a manager or forecaster, perceive that your forecast is highly dependent on the changes happened in previous period, such as the past month sales, then you want to choose high value such as 0.9 or 0.8. But if you think that the past change is not really important for your forecast, then you may want to go with lower number like 0.1 or 0.2, 0.3. So the higher the alpha, the more sensitive it is, and vice versa. And as a forecaster, your job is to choose the right alpha, pick the right value of alpha. Let's do another exercise here. Given an actual demand of 103, a previous forecast value of 99, and an alpha of 0.4, the exponential smoothing forecast for the next period would be what? So let's use the formula. Ft minus 1, the forecasted value is 99, and actual value is 103. So actual demand was 103, and forecast value is 99, and we know the alpha is 0.4. It's given. So calculate that, and you will find 100.6 is the answer. Let's do a little bit more complicated exercise. Use exponential smoothing method with alpha equals 0.2 to calculate smoothed averages and a forecast for period 7 from the data below. Assume the forecast for the initial period is 7. And how would you calculate this? So I'm going to be using Excel for this problem. And we learned that here alpha is 0.2, and one important hint is that assume the forecast for the initial period is 7. So it's important for you to understand that initial forecast is 7 here. And we want to apply the formula, which is ft equals ft minus 1 plus alpha times at minus 1 minus ft minus 1. So here I'm going to start equals forecasting equals ft minus 1, this one, plus alpha 0.2 times parenthesis actual forecast at minus 1 minus ft minus 1. So this is the formula that we are going to be using here. So once you do this formula, then the only thing that you have to do is we have to make alpha as an absolute reference because it does not change although you drag it down, and copy that down like this. And then the answer we find for period 7 here is that f7 equals 8.87. I'm sorry, 86 is the answer when you are using exponential smoothing method. So in this lecture, we learned about the power of forecasting. Forecasting is serving as the basis for decisions. It really helps us to create the future. So that's important. The second thing is we have learned the method of forecasting. There are qualitative versus quantitative forecasting. And we learned that forecasting is the art and science of predicting the future. Therefore, the role of a forecaster is very important because he or she has to use knowledge and common sense and artistic skills to come up with the right forecasting. And the method of forecasting we learned was moving average and weighted moving average and exponential smoothing methods.